Chances of winning money or love. I recently saw an interesting question on Twitter, where a father gave a challenge to his daughter's boyfriend and promised to agree to their marriage if he can answer it correctly. How do we solve the question? Since carrying coins has given me too much drama, I'll use dollars for coins in the following video. The question is asking for the probability of A winning against B, so let's denote Px to represent the chance of A winning with X dollars, where P is short for probability. A here is to clarify that the probabilities for player A. The last X indicates how much money A owns. This PAX can be transformed into two states, depending on whether A loses, which is PAX minus 1, or A wins, which is PIX plus 1. Remember, the chance of winning a bid is 50%, so we can write an equation like this to link the states together. It's also clear that the valid range of X is from 0 to 11. Since A has $1 and B has 10. Since Px is the probability of A winning the game, we know PA0 equals to 0 because A has already lost the game, and PA11 equals to 1, as A would have already won the game when A wins all the money from B. Now we need to find a way to figure out PA1, as there is $1 with A at the beginning of the game. By using the equation we just talked about and applying it to PA1, we will know how PA1 is linked to TA0 and PA2. By applying it recursively, we will get a list of states standing together. Let's list all of them like this. Notice we've already known PA11, so let's apply it to the equation for PA10. Then we simplified it a little bit. Let's try to replace P8n in the equation for P9 above. Then make the equation simpler. And simpler. And simpler. Let's repeat this process. Now I believe you already know this very well, so I'll make it quicker. Now we have finally reached PA1, and PA0 is already known to us. Then the final answer of the question is 1 over 11. Wait, what if the amounts of money A and B have are different, like A has $5 and B has $1,000? Then what would the probability be for A winning the game? Well, let me explain it again. Let's go back to this equation we had earlier. If we multiply by 2 on both sides, we get a new equation here. By rearranging the elements, we can express the equation differently, like the one below. Do you see the pattern here? If we follow it, we will see that this equation also equals Pix minus 1 minus Px minus 2. Let's do it again. And again until Pa1 Pa1. Ultimately, this equation is equal to Pa1 minus Pa0. Since the differences between all the elements are the same, this is clearly an arithmetic sequence. Although we don't know what the common difference is, it's denoted as C for now, where C stands for constant. Then the elements of the sequence can be rewritten as a formula that relates to P0, X and a constant C. Given that P0 equals 0, then the X element of this arithmetic sequence is X times C. When A has $5 and B has $1,000, A would win the game when A owns $1,005. So we know PA 1005 equals 1000 plus 5 times C, which is also equal to 1 as well. Then we can find out the constant C. In general, the probability of winning the game with X dollars initially can be calculated by this formula. If you like this video, please leave a comment and remember to subscribe. Thank you.